All right, today we're going to dive deep inside the engines and machines that power our entire world. We're looking at something we all rely on, but, probably never think about: industrial lubricants. We're on a scientific quest to make them greener. And let me tell you, the journey is full of some really unexpected twists.
So I want you to just picture it for a second. The engine in your car, the massive gears in a wind turbine, all the machinery in a factory. What's the invisible force that's working nonstop to make sure all those moving parts don't just, grind themselves into dust? You got it. It's lubricating oil. It's that slippery stuff that cuts down on friction, prevents wear and tear, and basically allows our whole mechanical world to run smoothly. It's absolutely essential. But there's a problem hiding in plain sight. See, most of the lubricants out there are petroleum-based. That means they come from crude oil, they aren't biodegradable, and when they spill or leak, they stick around in the environment for an incredibly long time. And that right there is exactly why scientists are on a mission to find a better, greener alternative. And this brings us right to the heart of the challenge. We need the same performance we get from traditional oils, but we've got to ditch the environmental baggage. Now, the obvious answer seems to be biolubricants, but as you'll see, they come with their own big set of issues. So here's the trade-off we're looking at. On one side, you've got your traditional petroleum-based lubes. They work great, but they're persistent and definitely not eco-friendly. On the other side, you have biolubricants, usually made from things like plant oils. They're renewable, they're biodegradable, which is fantastic. But, and this is a huge but, they have a kind of Achilles heel. They just break down way too easily under heat and stress. Okay, so the sciencey term for this breakdown is oxidation. And a really easy way to think about it is like the cooking oil in your kitchen. If you leave it out for too long, it gets all thick and sticky and just smells off. That's oxidation. Well, the same thing happens to biolubricants, except it gets supercharged by the crazy heat and pressure inside an engine, which makes them unreliable. Right, so here's the deal. If we can solve this oxidation problem, we could finally unlock the full potential of green lubricants. And a lot of researchers think the answer might lie in a secret ingredient, a specific kind of additive that's based on the element boron. So why bet on boron? Well, because it's kind of like a Swiss Army knife for chemistry. Scientists have found that these boron-based compounds, specifically something called borate esters, can do a lot of things at once. They have the potential to not only fight off that pesky oxidation, but also to reduce corrosion. And maybe the most promising part? They seem to play really well with other additives, boosting the overall performance of the oil. So what do you do with a theory like this? Well, a team of researchers decided to put it to the test. They basically set up what you could call a high-stakes lubricant bake-off to find the perfect formula, one that could stand up to the absolute toughest conditions. For this bake-off, they created 4 main contenders. Additives A and B were pretty standard borate esters. But C and D, they were special. The researchers actually bonded the boron with compounds that contain nitrogen, and they had a hunch that this specific chemical bond could be the real key to making a much, much more stable molecule. And to find the winner, they designed a seriously brutal stress test. They took a base biolube, mixed in one of the 4 additives, and then they cooked it at 150 degrees Celsius for 24 straight hours, all while bubbling air through it. That's a perfect recipe to speed up oxidation. The whole goal was just to see which lubricant would thicken up the least. The one with the smallest change in viscosity would be crowned the champion. So, after 24 hours of that intense heat and pressure, it was finally time to see which of these formulas actually survived the bake-off. And let me tell you, the results were incredibly clear. The results were pretty amazing. The base oil, with nothing added to it, saw its viscosity just skyrocket by 133%. It basically turned into sludge. The standard boron additives, A and B, they helped a bit, keeping the increase to about 112%. But the undisputed winners were C and D, the ones with nitrogen. They held that viscosity increase to just over 92%. It turns out that nitrogen made all the difference. In fact, the single best performing recipe of them all was a combination of that ester C and a specific antioxidant partner. Get this. It limited the viscosity increase to just 65%. That's more than twice as stable as the original biolubricant. What a huge success. And that winning partner was an antioxidant with a bit of a mouthful of a name. Phenol 1-naphthalene, so we'll just call it PNA. The tests showed that this specific antioxidant worked in perfect synergy with those nitrogen-boron additives, creating a powerful 1-2 punch against oxidation. So mission accomplished, right? The team had pretty much solved the oxidation problem. A high-performance, stable biolubricant was finally within reach. But, science is rarely that simple. As they looked at the rest of the data, they discovered a really unexpected and frankly confusing setback. Remember, one of the other goals was to improve corrosion protection. The researchers had even included a standard off-the-shelf anti-corrosion additive in all the formulas, just to be safe. So, did it work? The answer was a resounding nope. In fact, things actually got worse, a lot worse. This table shows how much weight was lost from little metal strips they put in the oil. As you can see, the base oil by itself caused very little corrosion, but once they mixed in that whole additive package, the corrosion on copper nearly doubled. The anti-corrosion additive was somehow making things worse. How was that possible? Well, the reason turns out to be something like a molecular traffic jam. As the researchers explain it, the boron additives and the anti-corrosion additive were literally fighting each other for space on the metal surface. The boron compounds were so good at sticking to the metal that they basically blocked the anti-corrosion agent from getting in there and doing its job, leaving the poor copper totally vulnerable. Now, this surprising twist doesn't mean the whole experiment was a failure. Not at all. In fact, this is how real scientific progress happens, through trial, error, and these kinds of unexpected discoveries. This whole bake-off taught us some incredibly valuable lessons. So what are the big takeaways here? Well, first, we now know for sure that adding nitrogen to these boron additives dramatically improves how well they fight oxidation in biolubes. That's a huge win. Second, we learned that creating the perfect formula is a really delicate balancing act. You can't just toss a bunch of ingredients together and hope for the best. You have to understand how they all interact. And finally, despite that corrosion setback, this research is a massive step forward in the quest to create lubricants that are good for machines and good for the planet. It just goes to show that even the most mundane, hidden parts of our world, like the oils sloshing around in an engine, are ripe for innovation. It really makes you wonder, doesn't it? What other essential technologies are being completely rethought and re-engineered right now for a more sustainable future? Something to think about. Thanks so much for joining us for this explainer.